Welcome to Think Max. We are dealing with Insert Class 10 Max Chapter 1 Real Numbers. So in this session we are going to discuss about extra questions based on Euclid's division lemma. Let us get into this video. So question number 2. Prove that n square minus n is divisible by 2 for any positive integer n. So we have to take a positive integer n and we have to take b is equal to 2. So we have to apply the Euclid's division lemma and find out whether n square minus n is divisible by 2. So as usual, we can take let n be a positive integer and b is equal to 2. Then by Euclid's division lemma, n is equal to 2q plus r for some integer q, and r will be greater than or equal to 0 and less than 2. So r takes the value 0 and 1. So when we apply r is equal to 0 here, n will be equal to 2q. When r is equal to 1, n will be equal to 2q plus 1. So for these two values, 2q and 2q plus 1, we have to check whether n square minus n is divisible by 2. So they have given n square minus n. So we can take n outside and write it as n minus 1. So instead of n, we have to substitute the first value 2q. So 2q minus 1. So already 2 is outside. So whatever be the values of this integer, this value is multiplication in 2. So we can easily say that n square minus n is divisible by 2. So for the next value, n square minus n is nothing but n into n minus 1. So next value is 2q plus 1. So instead of n, we have to substitute 2q plus 1. So here also 2q plus 1 and this minus 1. So this plus 1 and minus 1 gets cancelled. So the value will be 2q. I write 2q here. 2q into this 2q plus 1. So this is also a multiple of 2. So this value is also divisible by 2. So n square minus n is divisible by 2 for any positive integer n. So case 1, n is equal to 2q, n square minus n is n into n minus 1, which can be written as 2q into 2q minus 1. So here 2 is outside, so 2 is common for all, so it is divisible by 2. So next case 2, n is equal to 2q plus 1. So n square minus n is nothing but n into n minus 1. So instead of n, we have to substitute 2q plus 1. So 2q plus 1 here. So what happens? This value gets cancelled. Plus 1 and minus 1 gets cancelled. So 2q is here. So 2q is written here. So 2q into 2q plus 1. So 2 is common here. So 2q is divisible by 2. So in both the cases, n square minus n is divisible by 2. So thus n square minus n is divisible by 2 for any positive integer n. So next problem is question 3. Show that n square minus n is divisible by 8 if n is an odd positive integer. Here n is odd. And we have to show that n square minus n is divisible by 8. So n square minus 1. So we know that a square minus b square is nothing but a plus b into a minus b. We have to use this formula and we have to take a positive integer n. This n is odd. And we have to take b is equal to 8. After that, we have to apply the Euclid's division lemma. So let n be any odd positive integer and b is equal to 8. Then by Euclid's division lemma, there exists q and r such that n is equal to 8q plus r, where r takes the value 0, 1, 2, 3, 4, 5, 6, 7. So n is equal to 8q and r is equal to 0 and r is equal to 1, n is equal to 8q plus 1. So in the same way, n is equal to 8q plus 2, 8q plus 3, 8q plus 4, 8q plus 5, 8q plus 6 and 8q plus 7. Here they gave the condition n is an odd positive integer. So we cannot take the value 8q because n is even when it is 8q. So in the same way, 8q plus 2. This is also even because if we take 2 outside, the value is 8q plus 1 into 2. So in the same way, this is also even 8q plus 4, 8q plus 6 is even. So only 8q plus 1, 8q plus 3, 8q plus 5 and 8q plus 7 is taken. So in now all the 4 cases, we have to show that n square minus n is divisible by 8. So first case, so case 1, n is equal to 8q plus 1. So n square minus n is nothing but n plus 1 into n minus 1. So instead of n, we substitute 8q plus 1 and this one comes here. Instead of this n, we substitute 8q plus 1. This plus 1 and minus 1 gets cancelled. So only 8q will be here. So we can take 8q in front. So 8q into 8q plus 2, which is divisible by 8. So next case 2, n is equal to 8q plus 3. So we substitute instead of n, 8q plus 3. So 8q plus 3 plus 1, here 8q plus 3 minus 1. So 3 plus 1 is 4, 3 minus 1 is 2. So from this value, we can take 4 as common. So remaining will be 2q plus 1. Here 2 is common. So we can write remaining values as 4q plus 1. So 4 2s are 8. So 8 is taken outside. Remaining 8, 2q plus 1 into 4q plus 1. So this value is also divisible by 8. So next case 3. N is equal to 8q plus 5. So substituting n is equal to 8q plus 5. So 5 plus 1, 6, 5 minus 1, 4. So we can take 2 outside from this. The value will be remaining 4q plus 3. Here 4 is taken outside. The value will be 2q plus 1. So 2 into 4, 8. So 8 is taken as common. Remaining values are 4q plus 3 into 2q plus 1, which is divisible by 8. So next case 4, n is equal to 8q plus 7. So instead of n, we substitute 8q plus 7. So 7 plus 1 is 8, 7 minus 1 is 6. So here we take 8 outside. So 8 into q plus 1, the remaining values are written as such. So 8 is common here. So n square minus 1 is divisible by 8. So in all these 4 cases, n square minus n1 is divisible by 8 when n is an odd integer. So other values are rejected as it is even. So we can say that n square minus n is divisible by 8 if n is an odd positive integer. So that's all for this session. Thank you. Thank you for watching.